I can't do this. I know you guys got $5 million grant to do this, but I can't do this.
Again, complete coincidence. My one of my family members, he's running the nanotechnology laboratories at Georgia Tech. I remember whenever I came into, I think it was GTRI, which is a big research program at Georgia Tech, and I went into their semiconductor labs and suited up and see all the fun stuff that's going on at Tech. And then I sat in this conference room with a few friends, and we see this presentation about microneedle drug delivery. I was talking to my kids this morning about this conversation we're going to have, and they were like, "How do you deliver drugs to the eye? How do you deliver drugs in a way?" My 14-year-old, she has a gluten allergy, and we won't skip all the way ahead, but drug delivery, her first thing about having a gluten allergy is it just another shot? And, you can instantly see the emotion and the fear. And then when I said Samir was part of this project that allowed you to have drug delivery in the eye, they were like, how does that work? That sounds even more scary. So kind of tell us this evolution of PhD project, and that then evolution to starting your first biotech company.
So when I joined Georgia Tech, since I had worked already, I knew what I wanted to do. A lot of the students that were there went straight from some academic program, either just graduated with their bachelor's or master's, or were working in a lab and decided to get their PhD. So they hadn't yet figured out what they exactly wanted to do. I knew what I wanted to do. I wanted to be in the drug development world. And so I was very motivated, and I was fortunate that there was a professor here by the name of Mark Prousnitz at Georgia Tech who was doing drug delivery. That was his lab. So I made a huge pitch to him. I was like, hey, I'm here for you. I just left a job. If I don't get you, I don't know what else I'm going to do. And he had two projects. One was working in the microfabrication facility, making microneedles, trying to figure out how to use them for the eye. And I'm like, I'm on the application side. I don't want to work in a microfabrication facility, make a cool device that may or may not have an application, but I want to figure out how to solve a real problem. And so it was really clear, and he liked that approach, so he gave me that opportunity. And as an engineer, I come at developing treatments from the point of view of, hey, there's a lot of options out there. They're incredibly inefficient. Getting a drug to the target, which is a very complicated process, it seems easy, but if you think about the different ways you take drugs, they're all pretty standard. You take a pill, you take a shot, maybe you drink something. I mean, there aren't very many options, but if you want the drug to work effectively, it needs to get to the place in the body where the problem is. Otherwise, you're just exposing the drug to places where it doesn't need to be. And that's why you see ads with a minute worth of side effects, because a lot of those side effects come from the drug going where it doesn't need to be. You overdose yourself just to make sure the small amount that you need gets to where it needs to go. And so I felt like, hey, I can visualize this. I can see this as a problem. I can develop tools to address that. And so the microneedle was just a way to do that. And there's a lot of potential applications. And the project that I got was in ophthalmology. And fortunately, the lab was well funded. So I was tasked with a very specific problem, which was how do I get a drug to a specific part of the eye? And what they had asked me to do, I couldn't do. Like they expected me to inject in a part of the eye, and I spent a good part of a year trying to make that happen, and eventually had to tell them, I can't do this. I know you guys got $5 million grant to do this, but I can't do this. But I noticed I could do something else. And because I was paying attention and I had designed the experiments so that I could see those results, I ended up collecting that data and presenting to them. And by them, I mean my engineering advisor as well as my ophthalmology advisor. And my ophthalmology advisor got it right away. He was like, this is cool. This is a unique part of the eye. Nobody really has played around in that part of the eye, but I think it's manageable. We can deal with it even though you're creating something that doesn't exist yet. Uh, Engineering advisor was not there yet. He couldn't see how we were going to translate this into something meaningful. So it took him a little longer, but we eventually generated the data to do that. And that eventually became the basis for, hey, every time we presented this at the medical conferences and so forth, everyone said, "Hey, how can I test this out?" And that was the impetus for me to think we need to get this thing into the hands of the ophthalmologist who can then figure out if this can really treat something. And so we started the process about the time I was about to graduate, and we tried to license it to pharma companies and so forth. That didn't go over so well. So eventually we just said, "Hey, we're going to do this ourselves." And that was the basis for starting the company.